Hi, welcome to this session on SEM with Mplus. So here is our software of Mplus. So this is its interface. On its menu bar you will find options. The first option is the file. If you click file, then click new, so you will see a new window will open up. So this is called as input file. So in input file you write the commands for running analysis. So let me save it in some folder. So I'm going to save it in SEM folder. Then I need to visit my data set. So this is my data set. It's in SPSS format. So I have three variables. First one is the learning culture. Second one is the job satisfaction. And third one is the organization commitment. My first hypothesis is learning culture positively affects job satisfaction. Second hypothesis is learning culture positively affects OC. Third hypothesis is job satisfaction also affects OC. So let me prepare a data file which can be read by Mplus. So file, save as. So then save it as tab delimited .dat format. And then encoding as local encoding and uncheck the option of the right variables. Remember, you should not make any mistake in these three steps. You have to save it in tab delimited .dat format. Second, encoding option of local encoding must be selected. Third, the option of write variable names to spreadsheet should be unchecked. If you don't do any of these three steps, so this file will not be readable by Mplus. So save it. Remember, save it in the same folder where you have saved your Mplus file. So its name is sem.dat. Let me come back to Mplus. So here I write the command. So first one is the title. Title is SEM with Mplus. Semicolon. Semicolon is an indication that a command is going to end here. Second, data colon. File is equal to, here I need to write the name of the file. File name was sem.dat. Semicolon. Remember, if your data file is not located in the same folder where you have saved your input file of Mplus, then you need to give here complete path of the location of your data file. Then variable. Here you have to specify the list of variables. So I write here names are. Let me bring the names of variables from SPSS file. So correct this option of the variables. Control A and paste. So you see here list of variables appear here. Copy it. You can type it manually also, but there is always a chance that you can make some mistakes. So that's why I am bringing it from SPSS and save it. Paste it here. Now, keep in mind none of the command lines should have character more than 90. So I need to give a break at some appropriate points. So second break I give here and put a semicolon at the end of the list here. Then I write use variable R and copy this list, Control C and Control V, paste it here. Then I need to write a model colon. As you know that SEM model contains two models. The first one is the measurement model, second one is the structure model. So first I need to specify the measurement model. So what I do, I simply copy this list of the variables and paste it here. And you know that I have three constructs of the main variables, and LC is being measured by so LC1, LC2, LC3, LC4, and job satisfaction is being measured by so these four indicators, and OC is being measured by these 4 indicators. So sign this symbol of by means mean measurement. So these indicators are in fact the indicators which are measuring so this particular variable. So measurement model has been specified here now. Now I need to specify the structural model. In the structural model, if you recall, in the early points, I had mentioned that I have 2 outcome variables. One is the job satisfaction, and the second one is the commitment. So let me first write the name of the first outcome variable is the job satisfaction. It is predicted by LC. So I will write on JS on so LC and put a semicolon. Second is OC on LC and the second one is the JS and put a semicolon here. So you see here, so LC is positively going to determine JS, and LC and JS, they are predictors of OC. So this is the structural model, and the upper one is here, it is the measurement model. Now I need to put here options of the outputs. Output column here. First I need standardized. Second one I need SEM stat. Third one I need mod indices semicolon. Remember, there should not be any mistake in spelling in these commands, otherwise it will not run. Save it and run it. If all commands have been appropriately mentioned, so it will run successfully, and it has run successfully. Let's review the results. So you see initially, so it's a summary. So then you move on, here you find the mean values, then you keep scrolling down, covariances, correlations, then keep scrolling down, here are the fit indices. In fit indices, I'm more interested in chi-square. So chi-square, so value should be, chi-square per degree of freedom should be less than 3. And RMSES should be less than 0.05 ideally, however, up to 0.08 is acceptable. CFI and TLI's value should be ideally greater than 0.95, and then SRMR value should also be less than 0.05. However, it's acceptable up to 0.08. Now let me examine modification indices. So here are the modification indices. You see here the highest value of modification indices is 27. So it's in case of LC1 with LC2. Let me come back to my input file here, and here specify that LC in measurement model LC1 with LC2 and put a semicolon here. So here I am establishing covariance. So with mean covariance. So let me save it and run it again. So let me again review the results. So let me first examine the fit indices to see if there's some improvement. RMSE has improved. CFI and TLI both are perfectly alright, so there are no issue. So SRMR is also fine. Now let me see the loadings. Standardized loading. So standardized loading looks fine all cases. Then let me check the modification indices again. So no issue, not a big issue here. So then let me examine the R-square. R-square is this one. So since I have 2 outcome variable, one is the job satisfaction, second one is the OC. So it shows that 41% of the variation in JS is explained by the model, and 44% of the variation in OC is being explained by the model defined. Now let me examine the beta coefficients and their t statistics. So here we are. The first one, the LC's effect on GS is positive and is statistically significant. So the first hypothesis is accepted. Second one, LC's effect on OC is also positive and is statistically significant. So the second hypothesis is also accepted. Third one, GS effect on OC is also positive and is also statistically significant. So this is how we prepare a data file which is readable by Mplus and transform it into Mplus and write the commands and run the analysis. So thanks for watching.